may have to go back there and look it up on my paper because it's page 5. I know I did not skip quotient rule and everything when I taught this last year. Am I just missing a page? Let's see. Let's go back to the page 3. Ah, there. Well, gosh. I can't believe it doesn't have more quotient rules than that. Okay, there's the product rule down there. All right, well, let's see what Mr. Evans did wrong here. Because I will correct it and put it in the computer this afternoon for you. Because it looks like I left off quotient rules and product rules when I ran off my pages. Nope. It should be on that page that says 3.3. I wonder if it just didn't scroll down enough. Let's see. Cleared off at 24, it shouldn't have. It's supposed to be there, all right? And I put it on there. I downloaded it, but what I'm worried about is I can't figure out how to get, I don't know how to stretch this part of the picture out. Oh, there they are. There you go. If you just touch on it and slide up, there they are. There's your quotient rules, and there's your few product rules right there, okay? There's a few quotient rules, and there's a few product rules, okay? Now, you really don't have to use the quotient rule for 31 because what could you do to that first? You could reduce those, okay? All right, remember one I told you, if you just have a variable under it, you can just reduce all of them. Is that okay? So you really don't have to use the quotient rule there because you can just reduce it first. 33, you need to use the quotient rule. I taught you a shortcut. See 30 right there is a quotient rule. But those are your quotient rules. Honestly, if I can get you to where you can do quotient rule, you can do just about everything. All right? Quotient rule is the hardest one so far. Okay. I did product rule. And this one up here is called the what rule? It's called the quotient rule. Quotient rule. Okay, you can write that out there, quotient rule. All right. And when tomorrow and Friday, I'm just going to tell you to work all the odds on this page, okay? I'll just put tomorrow and Friday. You're going to work, it's Stewart 3.3, and you're just going to start at the top and work all the odds. Now, what you will notice is the key I will post Friday. The key will be added in on it on Friday. Now, somebody says, Mr. Evans, if you look through the pages, the key's already on there. And it may be at the end of this lesson plan that the key's already there, but if it's not, it will be on there Friday. What happened to my old? What if you just touch that and put 24 in there? I bet you can. Or 22. Okay, so basically not my strategy. Got to do it different than that. 21. Okay, we'll try that. Page 12. Okay, and this is going to be, and you're not there yet, but you'll notice there's quotient rule. These are, and then there's some trig we haven't gotten to yet. But that's what we're all going to do is learn rules on how to get the formulas for instantaneous rate of change. That's all we're going to do at the beginning. I think the key to this at the very end, the last page, page 24, I think has the key on it. Or 25. 20, if you go far enough down here, that's actually an old test. Notice this one. Given this whole thing, and then you have to find some information. All right? And the first thing you have to do is find that formula for instantaneous rate of change. And there's answer keys for that. But you're not there yet. I know that. But what I was going to tell you is I think, pretty certain, the key for this is at the end. Pretty certain I put the key at the end. If I didn't, I'll check it on the computer and I'll put it on the end later. Tell you what, let's go ahead and just work this problem right there. Okay? We'll just go ahead and work that problem right there. How much time do I have? I got enough time to work that, don't I? We're going to take a big jump. We're going to work the problem. Yeah, we're going to work an application, not just how to get the formula. Got to do this. And when I download this today, all that babbling I just did, I'm going to cut out. Nah, they won't do that. Okay, we're going to work question number 3 on the exam that I gave a while back on this. It's page 20 in the module. So we'll do module, page 20, number 3. We'll try to get some kind of notation. Okay, y equals x cubed minus 12x squared minus 60x minus 43. And we want to know the equation of the tangent at negative 3, 2. Equation of tangent at negative 3, 2. In other words, on this graph, if you were to graph this, which I'm not going to do, but if you were to graph that, negative 3, 2 is a point on that curve, and we want to know what the slope of the tangent is, and then what is the equation of the tangent. Fair enough? Okay. Now, if you look at the notice out there, it says P-O-N-C, PONC. That's telling you the point's on the curve. For this to work, the point has to be on the curve. All right? If the point's off the curve, there's a whole other way you have to work it. But for a point on the curve, it's pretty simple. Now, if you didn't know if it was on the curve or not, you put negative 3 in there and see if you get 2, which you would. But I just went ahead and told them, this is PONC. The point is on the curve. PONC. POC problem, point is off the curve. Different problem. Okay, well, let's use our formula. Before I use our formula, let's see if y'all remember something about equations of a line. Y'all remember that formula for equations of a line? Remember that? How many of you remember it? Raise your hand. Tell me something so I feel better. Okay. You don't remember because you slept through it. Okay, so it's going to be y minus 2 equals blank x plus 3. We've already got most of the equation written. All we got to do is find the slope of the tangent line. And remember, this little trick, dy over dx, tells us the what? Slope of the tangent line. So what we're going to do is we're going to do dy over dx equals 3x squared minus 24x minus 60. And then, in order to find the slope at negative 3, what are we going to do with the negative 3? We're going to put a what in there? Everywhere that they got there, we're going to put in what? Negative 3. Okay? So I'm actually going to write it out. 3 times negative 3 squared minus 24 times negative 3, minus 60, 27 plus 72, minus 60, 90, 99, minus 60 is what? 39. So the slope is 39. And there you go. That is the equation of the tangent line at the point negative 3, 2. Okay? So that easy. You just need the slope. You've already got the points, so just put the point values in. Now, I'm going to use this for my equations of tangent lines formula every time we do them, this equation of tangent lines, because this formula is real easy to substitute into. Now, you can simplify it to slope-intercept or standard if you had to. But I'm going to be honest, if you just leave it right there, you can do anything with it you want. Okay? And y'all remember that formula, the point-slope formula? That's the one we're going to use. If you want to rewrite it to slope-intercept or standard, I won't care. But I can stop right there and be happy. Okay? Cool? Any questions on that, since we did something a little bit off the wall right here at the end? Okay, well, that means the tangent line came across and touched right there. Is that okay? It's called the tangent line there, and we got the equation for it. Slope's 39, so probably it's really going up what? A lot faster. Okay? There's your tangent. Okay. You have this thing they use in physics called a normal line. Physics are always talking about normal lines. Something about friction. A normal line is perpendicular to a tangent line. A normal line. A normal line is just simply perpendicular to a tangent line at the point where they're tangent. You have the tangent line, and then the normal line is perpendicular to the tangent line. Is everybody writing that down as a little thing to remember? You got the tangent line. Well, a normal line is always perpendicular to it at the point of tangency. Okay? It's perpendicular. So if I were to ask you to write an equation for this normal line, would it be pretty easy to do? Yeah. Here's the normal equation. Normal. Y minus 2 equals blank x plus 3. And what goes in that blank? Negative 1 over 39, because it's what? Perpendicular. So if you know the tangent slope, the perpendicular slope gives you the what? Normal line. Okay? Notice we're reviewing some